Hey guys, it's Mr. Rysz. Now, if you are watching this for the first time, you don't realize that this is my third time recording this video. So you will actually see a cut where the video starts working again. Yeah, I've just had every issue here with the first time I did it. The writing didn't save at the beginning, and then I re-recorded, and then the audio didn't save. So we're going to try this again for the third time because just like a CYU or any of these assignments that you guys take, if you don't do well the first time, just retake it. Don't give up. So here we go. This is 1-1, and we're going to get this started. So 1-1, we're looking at the key features of a function. So hopefully by the end of this, you can interpret the key features of linear, quadratic, and absolute value functions given the equation of the graph. Normally what we will do is I will make these videos where I split them up. So we'll go through the first half of the notes and I'll stop the video, or the video will end and you'll take a CYU, and then there'll be another video for the second half of the notes. This is chapter 1, section 1. So we're going to go through all the notes, even though we will spend 2 days on this section here. Probably don't need to spend 2 days on this section, but it's the very first one. So I figure we'll take your time, make sure nobody gets lost on the very first lesson. Okay, so let's get this started with the warm-up. I'm going to zoom this out a little bit, and it'd be great if I can get rid of that. All right, here we go. That should be good enough for us. Okay, so let's go through this. A diver is going through the ocean in a search and rescue training. The graph shows the relationship between her depth and the time in seconds since starting her dive. So you can see here at 0 seconds, we're up at 2. She goes down 5 seconds at -8 feet. And up 9. So let's go ahead and let me annotate on here, and we'll start filling out some answers. So what details can you determine about the dive from the coordinates at 0.5, -8? So we can say at 5 seconds, we know her depth is at -8 feet, but that's the lowest to go. So at 5 seconds, she's the lowest at 0.5 seconds, we have the lowest point. That's a terrible L. Lowest point of 8 feet below. Okay, what is the average speed of the diver in the water? Okay, so let's look at the water. So from right here, she's in the water. So 1 second to 9 seconds, she's in the water. So we're just looking at that time there. Now, one thing, if you guys remember, speed is distance over time. So let's look at the distance here. The distance she travels, she goes down 8 feet and then back up 8 feet. So that is a total of 16 feet over the course of from 1 second to 9 seconds, 8 seconds. So what's the speed of that divide? That'd be 2 feet per second. And we can tell that just from that information in the graph there that we did. Okay, next. At which point on the graph shows the starting location of the diver? Okay, well, the starting location would be when the time is 0 right there. So that point would be at 0, 2. And so explain. So at the start, AKA 0 seconds, she is 2 feet above. But guys can probably hear my kid because I am recording this at home. All right, next question here. What does the V shape tell you about the dive? What information does it not? So if we look at the V shape, it goes down and then up. Come over here, Bo. You can learn some algebra 2 with everybody else. The graph goes down and up. So basically meaning we know she's going to go down 8 feet, and then it's not like she's staying there for a second, because that would be a flat line if she was like staying there and picking up seashells or something, but then goes right back up. So we know her dive goes down. She goes down and right back up. You want to try to learn? All right, let's see, Bo, how well you can do this next part. Okay, what does it not tell us? Well, the one thing about this graph only represents time and depth. So if you think about it too, like three-dimensionally, we don't know if she's jumping out the boat, going down 8 feet, grabbing something, coming right back up. We don't know if she's like getting tossed out of the boat and she's going down 8 feet and then over, you know, still going up. So she could go down like that. You want to draw on there, bud? Let's see, Bowie here. How well can he draw on it? Just pick a point. Maybe she goes down here and then Aquaman super fast that way, but it's still going up. All right, Bo, I need that back. Okay, so what we can add on here is we don't know the horizontal movement. Okay, so that's a nice little warm up to get our brain working for Algebra 2. Now we're going to kind of focus on the math that's involved here. So let me clear this all up.
I want to go down there.
You want to go down there? I'm going to scroll down. Okay, so Bo, are you going to be good here while we talk about domain and range, or do you want to go play with some toys? Bo, I cannot have you use this. Alrighty. All right, and I am back. So here we go, next part. Looking at domains and range. So if we had a question here, so what are the domain and range of the function y equals x squared minus 3? So the set of all possible endpoints for a relationship is called the domain. What you might want to do here is just to add the fact. I always think of domain and just make it easier to remember here. Domain is going to be a list of how far left and right does the graph go, and is there any holes? You know, sometimes there could be a hole, but you know, we want to know how far left can the graph go, how far right can it go. So if you think about it here in this function, if we're not looking at the graph, we'd have to think of, you know, are there any numbers that we wouldn't be able to square for this to work? You know, is there any number we could plug in for the x and we wouldn't get an answer? And no, there's not. So the domain of this one is going to be all real numbers. Now, there's a couple different ways we can write it. There's set builder notation, but to be honest, set builder notation is like a verbal description or an inequality set using the numbers. I will still use the verbal and say all real numbers, but we're going to use the interval notation because I think that's just easier for everybody to use. It's also easier to write down. So the domain of all real numbers looks like this. We can go all the way to the left of negative infinity, and then we can go all the way to the right of positive infinity. So our domain goes from negative infinity to positive infinity. The interval notation will always have like two numbers inside, and we're just going to name like how far left can we go, how far right can we go. All right, next we got to talk about the range. The range is the set of all possible y values. So if we look on our graph like the y, where does it go? And I think of it as how far up and down we can get. So what's the lowest point we can get to what's the highest point? So the range, we're still going to do the same thing like this. Now, if we look at this, the lowest number that we could square and have it still work would be 0. And when we plug it in, we get an answer of -3. So our range, the lowest we go on this graph is -3. And in fact, we do touch that. So we're going to use a square bracket since we do touch that lowest point. It's not like we just get up to it. -3. And the graph goes all the way up towards infinity. So on the range, it's how the lowest to the highest. Maybe we'll put that in here. Lowest to high, and then domain is how left, most left point, the most right point. All right, and then so the other part here, how high do we get? We get all the way up towards infinity. Now, this square bracket here is something that I will use. I'm not going to let you guys or worry about if you know the difference of whether to use a square bracket or a rounded bracket. I'm not going to nitpick on it this year. It's something you see, and it won't like I won't give you guys a multiple choice where you have to know the difference. But it's good that, you know, it's an easy thing to pick up though. Okay, so let's move this on here, and I believe I might be able to pause this recording and go back to the original first one that worked. So this is interval notation. This is what we're using. You can see set notation. I think it's just a little bit more confusing what we've been doing, and go. All right, so watch the magic here. I'm going to edit this video and we'll go to my first recording because it works now. righty.
Okay, so let's look at this one here. Let's write the domain and range of this. Now, honestly, finding the domain and range, just looking at the function, is a bit difficult. Like, it's hard to do without knowing what the graph looks like. So I would recommend getting out Desmos or your graphing calculator and doing that. So let's see, I'm gonna do a new share here. I can do my screen. I think this is what I can do here. That's CYU. Let's put up Desmos here. Let's split screen this, and I'm going to just double check that that's what you guys see. You see both of them. All right, let's go to the graphing calculator. Let's first graph this. Y equals, now to get the absolute value sign here, I'm going to go down here, click functions, and there should be maybe in the miscellaneous. No. Where is this absolute value? Here, boy. Oh, actually, it's not over there. It is right here. X minus 4. Okay, so now that we got this, we can look at this graph a whole lot easier. So domain, I would say, is the exact same thing in the other one. So I'm just going to put DNR here. Ooh, I want my pen. So the domain, negative infinity to positive infinity. It goes all the way to the left, it goes all the way to the right. The range, though, does have a low and a high. We have a low point here, which is at, not at 4, we're looking at up and down. The lowest it goes is 0, and we do include that. The highest it goes, well, it could keep going up forever, to infinity. Okay. Dang, I wish I could just do that here. All right, so pause the video if you need to write that down, but I'm gonna have to delete it so I can get to the next graph. All right, next we got y equals 6x minus 2x squared. Okay. Man, wonder if you guys can hear that thunder. Sounds pretty fun. I don't think I'm going on my run today. All right, so the domain. Hey, look at this. This will be a common thing too, especially when we're dealing with first functions. We're going to keep it simple. Domain. This graph would keep going to the left eventually and would keep going to the right. We could zoom out if we wanted to, but negative infinity to positive infinity is the domain. The range. Well, let's look at this one here. This one has a max of that 4.5. Yeah, it'd be 4.5. Did I type that in right? And then it would go all, so the lowest it goes is negative infinity. But we do have a maximum now of 4.5. Oh, I did the wrong bracket. All right, it does include that 0.4.5. Where's that? Over. God, that'd be tough to figure out without a graphing calculator. Ooh. Try that again. I'm staring at the wrong thing. I gotta use this pen here. Boop, boop, boop. Yeah, good enough. So it's that hard bracket there. Okay. So there's domain and range real quick. All right, let's go back to full screen these notes up here. Keep going. All right, x and y intercepts. So this would be the next point. So x and y intercepts are your starting and location for the y-intercept, typically in a story problem. And your x-intercept is where the graph crosses the left and right line. So we got another warm-up activity here. A car starts on the journey. Okay. Can't really have them both, so I'll just list them here. All right, starts on a journey with a full tank of gas. The equation y equals 16 minus 0.05x relates to the number of gallons of gas, y, left in the tank, to the number of miles traveled by x, where x and what are the x and y intercepts of the graph and what do they represent? So let's first see the x-intercept. The x-intercept is right here on the, where does it cross the, actually, no, it's not. The x-intercept is, sorry, calculus, we did y first. Get my brain mixed up. The x-intercept is over here. So the x-intercept is, we'll say, is at 320. And let's just do, for the sake of it, over here, the y-intercept. So you can see both of them. Ooh. The y-intercept is at the point 16, 0. Oh, geez. Not 16, 0. The y-intercept is 16. But we want to have it at. Oh, man. Good morning. 0, 16. All right. So hopefully you guys can see that x-intercept, this is review from like Algebra 1, even in geometry. Where does it cross the x-axis? It crosses right there at 320, 0. The y-intercept, where's that point located? Over 0, up 16. Now, what does that mean to our story problem? I think y-intercept's the easiest one to figure out. Remember, x represents the miles we traveled. Y represents the gallons that are in the car. Well, that means if we travel 0 miles, we would have 16 gallons. Or we could just say from there, okay, we start with 16 gallons. Now, what does 320, 0 mean? Well, 320 is miles, 0 is gallons in the car. All right, so if we don't have any gallons in the car, we got 320 miles, so we can go 320 miles on a full tank. I'm assuming they filled the tank up all the way. All right, some nice little warm up there to help us think about x and y intercepts and how do they relate. Now, how do we go through this? So, if we ever want to find x and y intercepts, we can graph it. It's totally fine to do. So if you want to use Desmos for this to look at your x and y intercepts, do that. The other way to do that is to do it analytically. So if I want to find the x-intercept, the key thing to remember, the x-intercept is going to be at the point something, comma, 0. So that means the y equals 0. So what we're going to do mathematically here is to make the y equal 0 and solve for x. Ooh, that should be a minus. Okay, so if we want to solve this, let's get the absolute value over. So when does 3 equal the absolute value of x? So what number, when we put it in the absolute value sign, does it equal 3? Well, definitely 3 does. And that's not the only one, though. Is -3 works as well. So we would actually have two x-intercepts. Maybe we'll double check this one on Desmos when we're done here, of -3 and +3. Now the y-intercept is always a lot easier. Y-intercept is always at 0 comma something. So when does the x equal 0, what do we get for y? So when y equals the absolute value of 0 minus 3, absolute value of 0 is 0. What's 0 minus 3? -3, and that's the only possible answer. So let's actually graph this one to double check here. Double check our work. We have 3, 0, -3, 0, and then 0, -3. All right, so let's go to Desmos. Can you guys see that? Yep. All right. We got the absolute value of x minus 3. And just click on these. Where does it cross the x-axis? -3, 0, and +3, 0. Where does it cross the y? 0, -3. Yeah, we're pretty smart. Guys, remember when you watch these videos, if you want to go back and rewind to go over these concepts, feel free to do that. Hopefully they're not too bad. Okay, next one. What's the x and y intercepts of this? Well, we could do the same thing, just type it into Desmos. But if you want to try this one on your own, feel free. Pause the video. But I'm going to keep going through. Okay, here we go. X-intercept. We're going to make the y equal to 0. Now remember, g of x is the same thing as y. All right, so it would be 0 equals 4 minus x squared. All right, I'm going to move the x squared over to the other side because I always like having positive x's. So x squared equals 4. So what number squared does it equal 4? Well, that would be 2, but actually not just 2, positive and -2. So we would have -2, 0 as our x-intercept and a +2, 0 as our x-intercept. Now the y-intercept, easier to figure out. We just make the y equal to, oh no, we make the x equal to 0. and solve for that. Well, here we go. Takes you about 2 seconds here. 0 squared 0, 4 minus 0 is 4. So we'd have a y-intercept at 0, x, 4 for y. Hopefully you did all right. And double check on Desmos. Okay. So this would be a good time to pause the video if you need a break, take it. But I'm going to keep going through recording these videos, see if the longer one works out all right. Maybe I could always timestamp these videos too on YouTube. We'll see how this goes. The next point are these positive and negative intervals. So the positive and negative intervals is where the graph is above the line or below it. So if we look at this graph here, this graph is above the line from everything from -3 to the left, and it's above the line from +3 to the right. So we would say that's positive. And if we're going to use interval notation, we would say from -infinity all the way up to 3. Now, the actual point 3 is at 0. 0 is neither positive or negative, so we're not going to use a hard bracket. And then we can say and. I like to just use that symbol. Some people use like a union symbol. It don't matter. We're just going to put it 1. Then from -3 or from +3 to infinity, it's also positive above the graph. Okay, now what is below the graph? What is negative? Negative is where we have all our y values are less than 0. So that's where everything is below the x-axis, and that's in between 3 and 3, or -3 and 3. Oh, I did see a mistake I made. Right here, that should be a -3. All right, so our negative, we're below the x-axis from -3 to +3. And that's the only point there. That's the only set we would have. And those would also be open brackets because those points, -3 and +3, are at 0, which doesn't have a value. Okay, so let's keep that concept going here as we move on. So let's look at the equation here. At h of x, let's just call that y. Y equals 2x plus 10. So where is it positive? Where is it negative? If you want, I think it'd probably be easier to graph this. So I'm going to take out Desmos. I think it's still okay. I think you guys can see that here. I'm just going to type in y equals 2x plus 10. Okay, so remember, positive and negative values is where it crosses the x-axis. So, okay, move that a little bit. So it seems like right here, the only time it crosses the x-axis is at 5 or -5. So if we're going to talk about positive, it is positive from -5 all the way over to infinity. So -5 is the lowest time it is positive. And then everything on to the right all the way up towards infinity and beyond Buzz Lightyear, it stays above the line. Now, negative is where is it below the line? Well, the lowest, remember, this is always kind of weird to think about, but the lowest number is -infinity. So let's write that out. So from -infinity, it's below the line, and it stays below the line until we get up to -5. All right, so hopefully that kind of clears some things up. The next one, a lot of people get these confused because now we're going to be looking at direction and not so much where its location is at. So we might have to draw a little bit more on. So increasing or decreasing functions. Increasing functions and decreasing functions is where the graph is going up in direction and where is it going down. Is that mine? All right, so if we have this graph here, we want to make a table where it goes up or down. So we are not looking at to see where is it above or below the x-axis. We are looking to see direction. Where is it going up versus where is it going down? And right here at 0 is the changing point. So we would say that this is increasing. I'm just going to put it here. From -infinity all the way up to 0. is where we get the change. So from negative infinity to 0, we are increasing. And then we can say it's decreasing. Well, it decreases from 0 all the way over to infinity. There you go. So that's how we'd write it in interval notation. So we got these two problems here, and this is actually where we end. We're going to skip this average rate of change. This is one of the things we're kind of cutting out the fat here. This will be something we talk about later. Kind of, I think it's confusing to toss to you right now. I think there might be a problem or two on your homework, but I just made them with 0 points. So if you guess it, get it right, awesome. If you don't, it won't hurt you. All right, we got these two problems here. We're going to figure out where they are increasing or decreasing. And I'm going to split screen this here because I think Desmos is going to be our friend when it comes to this. Can I put them both on the screen here? I think I can. All right, I'm going to look at, well, let's see if I can look at both the graphs at the same time. So we got y equals x squared, that is not, minus 4x. And then we got y equals negative 2x minus 3. Okay, that's a blue line there. All right, so red is A, blue is B. If you're colorblind, I apologize. Red is the curved parabola, B is the straight line. So let's stop this here, and I will start out with A. So I always like to see, all right, where's the change in direction? So this change in direction is coming in just this curved parabola right here at 2. Now, in calculus, we always go left to right. We don't start with positive and negative or increasing or decreasing. We just describe what's going on left to right. So I always kind of get confused here, but I will do my best. If we want to know when is this increasing, it is increasing from 2 all the way on. So from 2 to infinity, this is going up. That's how we write our interval, from 2 to infinity. Now, when is this graph going down? It's going down all the way, starting at negative infinity, all the way till we get to 2. It's going down. All right, so we would write that as from negative infinity to 2. And that's it. This graph goes in 2 directions. It goes down, then up, and that's why we only have 2 solution points, which is actually a good way to think about it. The amount of directions you have would be the amount of solutions. So if you had a graph that went up and then down and then back up, we would actually have 3 parts because we would have 2 times right here and right here where it increases and only 1 time where it decreases, which actually brings us to the next problem. We look at this, B, the negative 2x minus 3, that is just a straight, I'm just erasing this old stuff here, straight line going down the entire time. So is this line ever increasing? Nope. I'm just going to put no solution there. There's no time it's increasing. When is it decreasing? The whole time it's decreasing. So that would be from negative infinity to positive infinity. Now, hate to get really particular here. If you think a graph never has increasing, there's no guarantee that it's negative infinity to infinity. So one thing in calculus, we go over this, you could have a point that could be increasing like this, and then have a point where it's flat, and then keep going up again. That point where it's flat right there is not increasing or decreasing, so you would actually have to break this up into 2 increasing points where you'd say right there at that one point it's not doing either. Well, that's nitpicking. Okay, so that was all of lesson 1, and we will spend 2 days on lesson 1 just because we're taking our time with this. We're also trimming the fat, and I don't know how well you guys are going to go through this. So one thing at the end of the notes, there's always these key features. I'm just going to print off the notes from last year, so you're going to have this extra stuff that you guys won't need here. Don't worry about it. But here's some key features to look at, and they help you with domain and ranges if you're looking and you don't know. So always go back to it. You guys will have 2 assignments. You'll have CYU 1 and 2. So this will be your Tuesday and Wednesday assignments. I don't think there'll need to have a separate video for Wednesday. You can just watch this one over again if you need to, or you can reach out either in class or so. If you're here on Tuesday, we'll make sure you guys are notes and you're ready prepared to do Wednesday all on your own. If you weren't here on Tuesday, hopefully you watched this video and you can come into class on Wednesday with some questions. All right, guys, have a great day. We'll see you next time.